Good morning to one and all. Today we will learn about balancing and balancing of rotating masses. So, in balancing of rotating masses, you should know few basics, and out of them, the most important is centrifugal force, and which is equal to m into r into omega square. Where m is the mass of rotation, a rotating object, r is the radius of rotation, and omega is the angular speed of rotation. And balancing of rotating mass are divided into three. First, single mass, then several masses in same plane, and third one will be the most complicated, the several masses in different planes. And you can expect a question in part B from these two. Mostly it is asked from part 3, but you can expect it from part 2 also. That is several masses in same plane. Single mass, you will not be getting any questions, but it is necessary to learn it so that you will understand how to solve the other ones. So now we will go on about how to deal with balancing of a single mass first. Then we will further learn how to do it for several masses. So balancing of a single mass system. Rotating in a shaft. So balancing of single mass. So now consider a shaft. The shaft can be anything like crankshaft or any rotating machinery shaft. A shaft is rotating at an angular velocity omega, and it is having a mass m at a radius r. So this when this shaft rotates, what happens is due to this rotation, this mass will also rotate. And because of this mass is at a distance away from the axis of rotation, this mass will generate a centrifugal force. And you know centrifugal force will act away from the axis of rotation, and it will be pulling this shaft towards outside, or it will pull this shaft to one side when it rotates. So this will create a unbalanced force, and this will create vibrations in the shaft, which is unwanted for a smooth operation of machinery. So this force will be m into r into omega square, where m is the rotating mass, r is the radius of rotation, and omega is angular speed. So because of this unbalanced force, there will be vibration. So our duty, or our engineers need to balance this unbalanced force. So for that, the easiest option is, just a second. Yeah, the easiest option is to put a mass that will counter this unbalanced mass. So that is done by using another mass given to the shaft, that is known as balancing mass. We notate the mass of that balancing mass as B for balancing, and radius as lowercase b or small letter b. So what this will do is this will counter the centrifugal force, but it should be done in such a way that both the centrifugal force should be equal. So this will pull with another centrifugal force B into omega square. Omega remains the same because both are attached to the same shaft. So now what is the condition for balancing is that we should choose a mass B such a way that it is countering the centrifugal force created by the mass M. So our condition should be M R omega square should be equal to B omega square. This is the condition for balancing. We are not putting a mass that is equal to M and radius exactly equal to B or R, but we are putting a mass system which is of mass B and radius B such that it will create same centrifugal effect as that created by the disturbing mass M. This M is also known as disturbing mass because it creates a disturbance in the shaft. So to counter the disturbance, we are putting a balancing mass B. So B is known as balancing mass, and small letter b is known as radius of rotation of balancing mass. So radius of rotation of balancing mass. So our numericals will be to find either mass B or radius of rotation B of the balancing mass. And because this omega is same, we can deduce this equation into omega square. Omega square will be cut. Then what will remain is M into R is equal to capital letter B into B. So if you know either a radius of rotation of balancing mass B or this radius of rotation of the balancing mass B, then we can find mass of balancing mass because M and R will be known because those are the things that we need to counter or balance with. So M and R will be known and the radius will be known. You should find the mass of the balancing mass. Or balancing mass will be given, you should find the radius of rotation of the balancing mass. This is normally how the numerical comes.